Okay, 497. Multiplying fractions. Find 6 times 1/4 using repeated addition. I would put 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. Does my denominator change? No. Now I add the top. So I'm going to go 1, 2, 3, 4, 5, 6. 6/4. Let's practice writing this as a mixed number though. 4 goes into 6 one time. Make it a large number 1. 1 times 4 is 4. Subtract and get 2. Write a tiny 2. I'm ready to write it as a mixed number. So 1, because it's a large 1. I look around to find out what my denominator is. It's a 4, and there's a little tiny 2. Bonus question, what is 2/4 also equivalent to, Marcus? 1.5. Nice. We're on number 2. Look at the model and tell whether each expression is equivalent to the product of 3 times 1, 2, 3, 4, 5, 6, 7, 8 is the denominator. And colored in is 5. 1, 2, 3, 4, 5. Okay. What is the number sitting on top of Levi? He is getting so smart with that answer. 3 times 5 is 15/8. Okay. Let's go over here and see if anything matches. 5/8 repeated addition. Yes. 24/5. No, that denominator doesn't even match. Look at that.
What about number 1?
We're going through it looking at our work. Because remember, we always show our work, then we go back and find good answers.
Skip 5 times 3.
I haven't looked. I'm finding my answers first, so I'm checking out information I for sure know. 15 is sitting over top of what number, Levi? 15 times 1 is 15. 8 times 1 is 8. That matches this little guy. I'm going to put yes. I'm going to put 5 over top of 1. 5 times 3 is 15. 8 times 1 is 8. That also matches. The answer is yes.
Yes.
Turn the page.
Yes.
The number line below shows. Let's look and see what the first fraction is. 3/10. And then the little bunny goes hopping. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put 8. 8 times 3/10. Levi, what's 8 sitting on top of? 1. 8 times 3 is what number, Sawyer? 24 over 10. It's an improper fraction. Let's practice making it into a mixed number. I have 24 pieces of candy, Hadley. 24 pieces of candy and 10 kids. How many pieces of candy can they already get? Oh, good. Nice. Yeah, 2. 10 times 2 is 20. Subtract, get a 4. Write a tiny 4. We're going to erase some of this stuff to get out of our way. Then I take and I write a large number 2, because I have that here, a tiny number 4, and I look around to find my denominator. I can see it right there. And I'm going to practice reducing my fraction because I'm getting really good at fractions. I'm going to divide my fraction by 2. 2 goes into 4 2 times. 2 goes into 10 5 times. Let's go to 4. Label the number line below and use it to show 3/4. I'm going to find 3/4. Let's count the parts to find out what the denominator. They're divided into 4. What is 1 worth, Jake? 4/4. So this would be 3/4, 2/4, or a half, 1/4, 0/4. And I want to find the first one, which is 3/4. It's right here. X marks the spot. So I started from 0 and I hopped to the X. And that has got inside of it 1, 2, 3 pieces. And it wants me to hand out the pieces 3 times. So I'm going to count 3 more pieces. And I'm going to hop 3 more pieces. And I'm going to hop and land right there. That is at, this is 0 over 2, 1 over 2, 2 over 2. No one other voice should be on but mine. 3, ooh, these are not over 2s. What is happening? Because it's divided into 4s, the denominator's a 4. So I can see that this is equal to 2 1/4. And I'm going to check my work just by going and doing it the simple way, which is 3 times 3/4 over a 1. 3 times 3 is 9 over a 4. Mixed number. Let's practice switching it back to an improper fraction to a mixed number. So 9 divided by 4, 2, 8 minus, and write a little 1, 2 1/4. So your test might say, choose all the correct answers. This is a correct answer. This is a correct answer. This is a correct answer. This means the exact same thing. That's 4 ways. Actually, these are the same answers, aren't they? That's 3 ways to write the exact thing. Let's go down to number 5, and we get to draw funsies. This is your art for the day. I'm going to make a bar model, and it says the denominator is 5, so I'm going to make 5 pieces. And it wants me to color in 4 of them. Color in 4. Then it wants me to do it 3 times, which is the same thing as repeated addition. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Coloring them all in. Your model should look like that. How did it go? Let's add it together and find out. The denominator never, ever changes. So put that a 5. Then I'm going to add all the little x's up. 4, 8, 12. That would be the answer. Let's make it a mixed number for practice. 5 goes into 12 twice, times. Subtract, write a tiny 2. 2 wholes, tiny 2. The denominator never changes. This is the answer, this is the answer, this is the answer. Any of those work? It says choose all that apply. They might give you all of that. Number 6. Look at the model you drew in problem 5. Use the digits 2, 3, 4, 5, and 6 to write 2 different multiplication problems with the same product as that. Digits may be used more than once. I'm going to read it again. This one looks a little challenging. Look at the model you drew in problem 5. Use the digits 2, 3, 4, 5, and 6 to fill this in. Okay, but I have to get to the same answer. So something I might do is I would say 6. I need to get the top to be 12. Can you see it has a 12 up here? I need to make it so it is 12 fifths. So I know for sure my denominator is going to have to stay a 5. 6 times what equals 12, Freya? 2. Okay. This one, the denominator has to be 5 too, so I'll just put that one in because that one can't change. And I'm going to pick 2 numbers that I multiply together to get 12, and it can be 2, 3, 4, 5, or 6. What do you want to do, Hank? 2 numbers. 3 times 4. So he can make a 3 here and a 4 here. Or he could do a 4 times 3 fifths, because that one would be the exact same thing. Because Levi tells us every day that 3 is on top of a little tiny 1. I'm on to 7. Casinda says that 3 times 6, Levi, what's it on top of? And 3 plus 3, 6 plus 3, 6 plus 3, 6 is the same value. Well, I'm going to do the work. 3 over 1 times 1 over 6. 3 times 1 is 3. 6 times 1 is 6. Or, Marcus, what does that also equal? 1/2. Then I'm going to do this problem here. 3 over 6 plus 3 over 6 plus 3 over 6. The denominator when I'm adding, does it ever change, Tayden? Never changes, leave it alone. Then I add the top together and I get 9. Does this match anything here? No. So the answer is no way. No way, Ray. Not the right thing. One of them is 9, 6. One of them is 3, 6. That's not going to work, Mrs. Casinda.